Have you ever stopped to think about the surface of, well, just about anything? You know, that phone in your hand, the bridge you drive over, even something like a medical implant. We kind of see them as simple, solid objects, but in reality, their surfaces are these incredibly complex engineered worlds. So today, let's dive right into this hidden science of advanced coatings.
At first glance, you'd say not much, right? I mean, one carries oil, one becomes part of a person, and the other one harnesses the wind. They all operate in completely different worlds, facing wildly different challenges. But they all share a secret, a common thread that's absolutely essential for their function and really for their survival. And yeah, that secret is a coating. And we're not just talking about a layer of paint here. We're talking about a highly advanced, meticulously engineered surface that's designed to do a very specific job. Today, we're going to peel back that layer and see the incredible technology that lies right on the surface of everything. Okay, first up, let's talk about the most fundamental job a coating has, to act as armor. You know, it's a constant battle out there against rust, wear, and tear, and these coatings are our first and best line of defense. Just look at the dramatic difference a coating makes. On one side, you've got your standard unprotected steel, totally vulnerable to the elements. But then you apply a mechanically deposited zinc-tin coating, and you get the result on the right. Research shows this coated steel can fight off red rust for over 240 hours longer. The coating itself is more compact, it's more resilient, and it even passivates, which is a fancy way of saying it forms its own protective oxide layer. It's basically reinforcing its own defenses all the time. So how do we actually measure this improvement? Well, scientists found the zinc-tin coating has a self-corrosion potential that's 68 millivolts more positive than a standard zinc coating. Now, in the world of electrochemistry, that is a huge leap. Think of it like a battery's charge. A more positive potential means the coating is way less willing to give up its energy and corrode. It's just a much, much tougher shield. And this isn't just for, small parts. We're talking about the massive infrastructure that powers our world. The gigantic monopiles of offshore wind turbines getting battered by salty seas, the critical welds on pipelines, and those high-stress parts in aerospace and cars, they all depend on these advanced coatings to survive. But what if a coating could do more than just sit there and take a beating? What if it could actively change how the surface itself behaves? Well, this is where we move from just passive protection to some truly active surfaces. Let's talk about a real-life superpower, superhydrophobicity. It sounds super complex, I know, but the idea is simple and, honestly, amazing. It's a surface that hates water so much that a droplet can't even spread out. Instead, it beads up into this near-perfect little sphere and just rolls right off, taking all the dirt and dust with it. So how does this actually work? It's a really brilliant bit of physics. First, engineers create this complex, rough texture on the surface at a microscopic, even nanoscopic level. This intricate structure then traps a stable layer of air. And here's the key. The water droplet isn't really sitting on the material itself. It's floating on this tiny cushion of air, which allows it to roll away with almost zero friction. And this isn't just some theory, Researchers have already created these things. This quote actually comes from a study on a silicone coating that achieved a contact angle of almost 155 degrees. Just for reference, 180 degrees would be a perfect sphere. So this is a real, functional, self-cleaning surface, all created by engineering at the absolute smallest scales. Okay, so from protecting steel to repelling water, coatings are already pretty impressive, but their most personal and maybe their most profound application is inside the human body, where they actually help us heal. When you put an implant in the body, you face these huge challenges. Will the body accept it? Will it get infected? Well, advanced coatings are the answer. Take a hip implant, for instance. A bioactive glass coating can actually encourage your own bone to grow right onto it, making it a true part of you. Or think about a biodegradable stent. A zinc oxide coating can control the exact rate at which it dissolves, making sure it does its job for just the right amount of time. These coatings are, and I mean this, truly revolutionary. They turn inert objects into active healing tools. And this, right here, illustrates the ultimate goal. The coating acts as a kind of translator, a diplomat between the artificial thing we've made and our own biology. It transforms a piece of metal or polymer from a foreign intruder into an active, functional, and accepted part of our body. So, we've seen these incredible applications, from massive infrastructure to inside our own bodies. But that raises a big question. How were these amazing surfaces actually created? Well, the methods are just as advanced as the coatings themselves, blending chemistry, physics, and engineering. Here's just a quick look at the toolkit. For super targeted repairs on high-wear parts, you might use laser cladding, which is kind of like a high-precision welder. To create an ultra-thin ceramic layer on a complex shape, the sol gel method is perfect. It builds the coating molecule by molecule from a liquid. Electrolysis coating uses a clever chemical reaction for perfectly even layers, and plasma electrolytic oxidation uses plasma to literally grow a tough ceramic-like shield on lightweight metals like aluminum. And it's not just the methods that are evolving, it's the ingredients too. We're moving into an era of revolutionary materials. Scientists are integrating graphene, that's a single atom thick sheet of carbon, into coatings for incredible strength. And they're using high entropy alloys, which are these complex cocktails of multiple metals that create surfaces with just unprecedented durability.
So, as we wrap up this explainer, the key takeaway is really this. Coatings are one of the most important and maybe most overlooked technologies of our time. They are the invisible, unsung heroes that protect our infrastructure, enable new functions, and even help our bodies heal. They're foundational technology, quietly making our entire modern world possible. So, the next time you see a skyscraper, or a wind turbine, or even just a nonstick pan, maybe you'll think about that incredibly thin, incredibly powerful layer of science that makes it all work. What are you going to look at differently now?